In this module, we are graphing the equations that they give us and then solving using that graph to find the common solution to both equations. Let me show you what I mean. The first equation they give us, y equals negative 1/5 x plus 4, well, that's in y equals mx plus b format, right? So what does that mean? Well, y equals mx plus b format. The number by the x, right, or the coefficient of the x is your slope, and the number left over here is the b value, or the y-intercept. So that just means that b is 4. So the point that our blue line crosses the y-axis, the y-intercept, is right here at 0, 4. Of course, the first number to the y-intercept is 0 because it's on the y-axis. So let me just change this pen tone right here. Okay. It's kind of blurry, sorry about that. So this point, as I said, is the point 0, 4. And next we have the slope negative 1/5. So negative 1/5 can be thought of as moving down 1 because think about slope for a moment. This point is slope. So m equals delta y over delta x. That means slope equals the change in y over change in x, or rise over run. And that equals negative 1 over positive 5. Notice the 5 could be thought of as positive, and the 1 could be thought of as negative. You could reverse that. I'll show both. You could think of as 1 as positive and 5 as negative, but not both numbers are negative, right? If both numbers are negative, you would be dividing two negatives and get a positive. So if you see a negative slope, either the numerator or denominator should be treated as negative, the other one positive, and that makes sense because slope here, negative slope or negative correlation you might call it, the variables behave differently. So if one is moving negatively, the other is moving positively, or if one's increasing, the other is decreasing, or if one's decreasing, the other is increasing, they're moving in different ways. That just means here, if I start at this point, negative 1, I can think of going down once on the y-axis, and then positive 5, up 5 on the x-axis to this point right here. I could have also reversed that, like I said, and gone up once in the y direction, a positive 1, and then negative 5 in the x direction here, which would land me to this point. But really, all of these points would be on the same line, right? Oops, let me just fix that, sorry. So when you're graphing this, right, use the slope in either way. So that's our blue line right there. Okay, so I'll write this, and I'll label it because I know I'm scrolling up and down, it might be hard to follow. And always check, yeah, this is a negative slope. You can see as you're moving to the right, or as x is increasing, the height is getting less and less and less. So that means as x is increasing, y is decreasing. The other line, negative 2x minus 5, well, here the negative 2, that's your slope, right? And negative 5, that's your y-intercept. So I'll rewrite the equation here. So y equals negative 2x minus 5, negative 5 y-intercept, that's the point right here. 0, negative 5, it's always a number that corresponds to the y-axis value, and negative 2 is your slope. So in case there's some confusion there, that means m equals negative 2 over positive 1, or 2 over negative 1, right? Rise over run. So that means, let's say we do 2 over negative 1. 2 corresponds to your rise, so you go up twice, and then negative 1 means back 1 on the x-axis. That would bring you right here. Up 2, back 1. Also, we could go down 2, right? So the negative values on the rise, so we actually go lower, and then up 1 here. On the x-axis, those 3 points are on the same line. So here's our graph here for this line. Now if you extend this, right, you extend it, you see that it's going to be crossing, right, our other line at a point. And I think my graph's a little bit off here, but let me fix it. Sorry about that. They're going to cross this common point, and that point would be your answer. So here the answer is negative 5. 5, that's the point where both lines cross each other, the green and blue. So if we go back up, what does that mean? That means that negative 5, 5, that's our point, right? And let me just clear off some of this so we can explain what this means. Clear this off. Oops, okay. That means negative 5, 5. Well, negative 5, the first value, that's your x value, and the second value is your y value. That means if we plug in negative x, negative 5 is, if we plug in negative 5 for x, In both equations, we should get positive 5. For a y value, let's just plug that in to see that it works. So here, right, in this first one, if I plug in negative 5 for x, I have negative 1/5 x. So that's negative 1/5 times negative 5 plus 4. Negative 1/5 times negative 5, that's positive 1, right? Plus 4 equals 5. So just check this out. We plugged in negative 5 for x, and we got 5 for y. Exactly what the point should do. Let's plug in the next one. If I plug in negative 5 for x, I get negative 2 times x, that's times positive 5, minus 5. Negative 2 times 5, that's negative 10. Minus 5, right? What's that? Well, negative 10 minus 5. Oops, I made a mistake, sorry. I'm plugging in not the value for y here, but I'm plugging in negative 5 for x again. Sorry about that. So negative 2 times negative 5 is positive 10. Positive 10 minus 5 is 5. So just to recap what we just did, especially since I plugged in the wrong number, sorry, is you'll have a common point for both equations. Plug the x value into both equations to make sure you get the correct corresponding y value. And we did. We plugged in negative 5 to both equations, and both times the output was positive 5. So this point is a solution for both lines. Thanks.